Welcome to another episode of the MRP Easy Manufacturing Podcast. In this episode, we explore what overall equipment effectiveness means and how to leverage it. Your equipment is running, your team is working hard, but for some reason, production numbers don't match what the specs promised. Overall equipment effectiveness solves this puzzle by measuring the true productivity of your manufacturing equipment. So, what is overall equipment effectiveness? Overall equipment effectiveness, or OEE, is a key performance indicator for manufacturers that measures how efficiently a machine or production line is working compared to its maximum potential. It relies on three metrics: availability, performance, and quality. The formula is simple. OEE equals availability times performance times quality. OEE shows the gap between the theoretical output of a machine and its actual output. It helps determine where bottlenecks or inefficiencies exist in your production lines. It's often used together with capacity utilization calculations to develop initiatives that improve OEE in your manufacturing process and increase profitability. What's a good OEE score? An OEE score of 100% may sound like a dream come true. However, that score is unrealistic and generally unachievable. In many cases, a good OEE score depends heavily on the type of industry you're in. Here are some standard benchmarks to consider. An OEE of 85% or higher is considered world-class in manufacturing. Only top performers reach this level. A score between 60% and 85% is typical for many manufacturers and is still a respectable score. A score between 40% and 60% is considered below average and indicates significant room for improvement. An OEE below 40% indicates that there are major efficiency issues that need to be addressed immediately. As mentioned, the fact is that a good OEE score is highly dependent on the industry standards it adheres to and how it operates. For example, in discrete manufacturing such as automotive, electronics, and furniture, a higher OEE score of 85% and above is quite achievable and even expected. These industries create individual, countable components or products, hence the name discrete for that type of manufacturing. Additionally, automation is highly prevalent in these industries, dialing out much of the human factor. Process manufacturing is different as it usually produces products in bulk quantities. They are measured rather than counted, with a few notable exceptions. Some representative industries are food and beverage, chemicals, pharmaceuticals, and paper. 75 to 80% is a respectable OEE score because of the cleaning requirements, batch changeovers, and regulatory compliance requirements. Similarly, high-mix, low-volume operations will inherently have lower scores of around 60% because of routine, fairly constant changeovers and slow cycles. This will become clearer when we discuss the factors that go into calculating the KPI. Finally, continuous operations that run 24/7 should aim for and target 85% or more since they are maximizing capacity utilization. The best OEE score is really the one that's improving over time relative to your baseline. In reality, a 5% increase can have a significant impact on your operations. Applying continuous improvement practices is more valuable than aiming for an arbitrary number without taking into account the constraints and challenges built into your industry. Now, let's take a closer look at the three pillars that make up overall equipment effectiveness. The first pillar is availability. Was the machine ready to run? Simply defined, the availability score measures the percentage of scheduled production time during which the equipment was actually running and able to produce product. In other words, when you needed it to run, was it running? This will determine availability losses. This can be determined using one of two calculations. Availability equals runtime divided by planned production time. One of the main contributors to availability is planned downtime or setup and adjustment tasks. Depending on the type of operation, this could mean changing over between product types, changing tools, or making adjustments and calibrations during a run. It could also include scheduled cleaning, especially in food processing, or warm-up time in processes like package sealing and shrink wrapping. Performance. How fast did it run? The performance factor measures how fast the machine or production line was running compared to its theoretical ideal speed, or its design production speed. In other words, even if the machine was available and running, was it running as fast as it should have been? There are two common ways to calculate performance. The first formula is performance equals ideal cycle time times total count divided by runtime. Another way to look at it is performance equals actual output divided by the theoretical maximum output during runtime. It's essential to note that this number is based on actual production output, excluding product quality considerations. It includes all pieces produced, both good and defective. You're measuring equipment speed, and that is all. However, this is a bit of controversy in the manufacturing community. Determining what number to use can also be tricky. Often, manufacturers use one of three options to determine the maximum speed. Some use the nameplate or design speed. Others use a proven maximum, i.e., the fastest documented speed achieved. Still others use the speed they maintain for a full shift without quality issues. That's more realistic, but giving the lowest performance expectations can also risk skewing your calculations. I might suggest one of the first two options, but whatever you choose, be consistent. Quality. How many were good? While performance didn't take defects into account, the quality metric does. The question you'll be asking is, how much of everything that was made is actually usable? Most of the time, quality losses fall into two categories. Process defects are the parts that fail inspection or are discovered during the production process. They may include dimensional errors, surface finish errors, or assembly problems, such as in furniture manufacturing. Startup losses are those that occur before production gets into full swing. For example, the first pieces after a changeover might not meet spec. These first pieces are often used to dial in calibration and are test pieces. Or sometimes when heat is part of the process, equipment may not have warmed up enough for the first few pieces. The 6 big losses where efficiency actually disappears. The 6 big losses framework breaks OEE down into specific, actionable loss categories. Think of them as the usual suspects when production efficiency goes missing. Understanding which of these 6 losses is affecting you the most tells you where to focus your improvement efforts. The 6 big losses are equipment failure, setup and adjustments, idling and minor stops, reduced speed, process defects, and reduced yield. They are mapped to the 3 OEE pillars like this. Under availability, the main losses are equipment failure and setup and adjustment time. Under performance, the main losses are idling and minor stops and reduced operating speed. And finally, under quality, the main losses are process defects, such as scrap and repairs, and reduced yield, which usually happens between startup and stable production. The reason for mapping these losses is simple. You need to know where to put your efforts into improvements and whether they will make a big enough impact on your OEE. After working years in processing machine maintenance, I can tell you for a fact that the leading cause of equipment failure is inadequate preventive maintenance. And some companies think they can't afford to schedule downtime for preventive maintenance. Those are the companies that spend even more time and money on emergency repairs that could have been avoided. Setup and adjustment are, to some extent, built-in time stealers. There's no way around them. For example, a tooling change on a CNC machine takes time, as does changing dies on a stamping press. But using the same strategies used in increasing capacity utilization, you can cut that time down. Calculating overall equipment effectiveness. Now that you know the basics of the different components, let's put this in a real-world example. But first, a hard truth. You must get accurate data to get accurate results. Let's start with a simple calculation scenario. Basic OEE example. Your company manufactures widgets. Your machine can theoretically produce 100 widgets per shift, but during the shift, it was only available 90% of the time. It also only ran at 80% of its design speed. When the widgets were inspected, only 95% of them were good. The remaining 5% had defects and either needed rework or ended up in the scrap pile. Therefore, your formula is 90% times 80% times 95%, which equals an OEE of 68.4%. That means you managed to produce 68 good widgets out of a theoretical 100 widgets per production shift. The other 32 widgets were lost, possibly due to downtime, slow speeds, or defects. Real-world OEE example. As you might guess, not every OEE calculation is as simple as that. When you add in the three pillars and potential 6 big losses, things can get more complex. Let's lay out a scenario that is more accurate for real manufacturing. Let's say you're running a 10-hour production shift. That means your potential production time is 600 minutes. You also have a scheduled break of 30 minutes, which makes your total planned production time 570 minutes. Availability calculation. During the shift, you had several interruptions. The setup at the start of the shift took 45 minutes. Then there was an unplanned breakdown, maybe a motor issue, which stopped production for another 30 minutes. Minor adjustments throughout the shift also resulted in 6 stops of 5 minutes each, adding another 30 minutes of downtime. Altogether, those interruptions added up to 105 minutes of downtime. That means your actual runtime dropped from 570 minutes to 465 minutes. So your availability calculation is runtime 465 minutes divided by planned production time 570 minutes. That equals 81.6%. In other words, you lost nearly a fifth of your runtime to stoppages. Performance calculation. Now, you need to calculate how fast your equipment was running. According to the design specs, the ideal cycle time is 2 minutes. That means you could potentially produce 232.5 units during your 465 minutes of runtime. However, the machine actually produced 204 parts. Your performance calculation looks like this. Performance equals ideal cycle time times total count divided by runtime. In this example, that means 2 times 204 divided by 465. That equals 87.7%. So your machine ran about 12% slower than its design speed, possibly due to one or more reasons. Finding those reasons may require a root cause analysis. Quality calculation. The last factor to analyze is quality. This is where you find out whether the products meet your quality standards. Let's say that out of the 204 units produced, 196 passed quality control inspection, while 8 parts had defects or needed rework. Here's the math. Quality equals good parts divided by total parts. In this example, that means 196 divided by 204, which equals 96.1%. Putting it together, the OEE calculation. Now it's time to put the pieces together and calculate OEE. OEE equals availability times performance times quality. In this example, that means 81.6% times 87.7% times 96.1% equals 68.8% OEE. So what does that 68.8% really mean? It likely means you have some work to do. While you had a theoretical capacity of 285 good parts, your production process only yielded 196 good parts. This comes out to about 68% of your theoretical capacity. To put it another way, you lost 31.2% of your capacity to one or more of the 6 big losses. This is not unusual. In fact, it is fairly typical for many manufacturing operations. However, it still shows that there is plenty of room for improvement. Now is the time to perform a root cause analysis, pinpoint the problems, and come up with solutions. You will not solve everything at once, but incremental improvements can make a real difference, and they are easier to implement and track. OEE versus TEEP. TEEP, or Total Effective Equipment Performance, is another workstation efficiency KPI closely related to OEE. Their difference can be summed up in one sentence. OEE measures how effectively you use your scheduled production time, whereas TEEP measures how effectively you use all the time you could be producing. So to put it simply, OEE is calculated on planned production time, while TEEP takes into account all available time, 24 hours a day, 7 days a week, and the complete calendar year, including holidays and weekends. Why is that relevant? TEEP helps to uncover potential capacity utilization increases. This number is used to inform strategic decisions such as increased shifts or investing in new and additional equipment. That said, there may be a point where adding capacity is counterproductive and may be less of an asset than a liability. The importance and challenges of tracking OEE. Tracking OEE is important for any manufacturer. It serves as a way of improving production, often gaining capacity without an excessive expenditure of capital. But it's not without its challenges. There are times when someone cooked the books to make the numbers look better. That does nothing to help the business's bottom line. Here's a common scenario that happens way too often. A manufacturing management team gets excited about measuring its OEE. They implement the proper tracking solution, like an MRP system, and then they discover their OEE is terrible. The management team panics at the numbers, and someone adjusts how the calculation is made. The OEE looks much better, and everyone breathes a sigh of relief, but nothing actually improves. Here's how tracking OEE can go wrong. The numbers game. Facilities often start manipulating OEE within months of tracking it. They redefine planned production time to exclude inconvenient downtime. They set unrealistically low ideal cycle times so performance looks better. They don't count rework as defects. Why? Because bad numbers are embarrassing, and nobody wants to report 58% OEE to executives. The cost. You can't improve what you won't honestly measure. The blame trap. The fastest way to kill OEE tracking is by using it to punish people. Post-shift rankings. Tie bonuses to OEE. Publicly call out underperformers. Watch what happens. Operators stop reporting downtime. Adjustments get called planned maintenance. Quality issues disappear from paperwork but show up with customers. The cost. People game the numbers instead of fixing problems. Next, there are data quality issues. Manual tracking sheets, operators logging downtime from memory, no verification of numbers, and downtime reasons are missing or wrong. All of these issues lead to beautiful dashboards built on garbage data and lead to terrible decisions. The cost. You're confidently wrong instead of roughly correct. Finally, the track but don't act problem. Facilities spend thousands of dollars on OEE tracking systems, generate impressive reports, hold monthly review meetings, then nothing changes. Problems get identified but never fixed. Data gets collected but never drives decisions. The cost. Wasted effort with zero return. Tips for increasing equipment effectiveness. First, remember to take into account the industry standards you're working in before getting too worried and choosing a viable target. Here are some tips for improving, no matter what your business manufactures. If your OEE metric is below 60%, focus on the obvious. The problem is likely staring you right in the face. That's not uncommon. Often, small things happen that get forgotten or swept under the rug because they seem unimportant. I've seen this dozens of times in my 36-plus years of experience. I'd recommend starting with evaluating and fixing equipment reliability issues and implementing a basic, yet thorough, preventive maintenance schedule. Make sure each machine is running optimally, and you may discover your numbers starting to go up. In fact, you may see your OEE number reach close to 75% by doing this easy step. If your OEE score is 60 to 75%, recover the hidden losses. If you're looking at these values, chances are you've gotten your equipment issues fixed and are ready to tackle the hidden losses. Minor stops are the order of the day here. For example, maybe you see brief jams that are cleared quickly before moving on. 8 stops times 30 seconds could be 4 minutes of lost time per shift. Over the course of a year, that comes up to 13 hours of lost manufacturing productivity, multiplied by the number of workstations where this is happening. 2 other areas for opportunity are changeovers and startup scrap. Better organization for changeover operations could yield as high as a 30 to 40% decrease in lost time, often by just organizing the tools more effectively and standardizing the procedure. The best part is that it costs zero money. If you get a lot of scrap from tuning in your machines at startup, find out why. Check and see how your operators are adjusting their machines. I'm willing to bet that one operator has a system down to minimize scrap. Find out how, document it, and teach it to the others. Again, it costs nothing but the time to find out. If your OEE is above 75%, optimize and sustain. If your OEE is running about 75%, then you deserve a pat on the back. Your operation is performing better than most companies. But keep up the good work to sustain that effectiveness percentage. A key here is focusing on consistency. You may have low days and high days. It's time to look for ways to smooth out those peaks and valleys. Find out what's different on your best days and see if it can be replicated all the time. You can also look for ways to run faster without sacrificing quality. Test new line speeds, for example, and document the results. Often, a manufacturing process will run at one speed because it was necessary back in the day. But things have changed, and it's time to question long-held assumptions. Regardless of your starting point, do these first. Get honest baseline data before anything else. Track OEE consistently for at least 2 weeks. You need your true starting point, not your best day or gut feeling. Identify your top 3 losses by category. Is availability killing you? Performance? Quality? Pick the pillar with the most opportunity and focus there first. Track progress monthly with the same calculation methodology. Don't change definitions to make numbers look better. Bad news in accurate numbers lets you fix problems. Good news in manipulated numbers lets problems compound until they become crises. Always remember that consistent, constant action is the key to progress in raising your OEE numbers. MRP Easy automatically converts inputs from the shop floor into an easily understandable OEE graph. Simplify KPI tracking with manufacturing software. Manual data tracking of the stats you need to perform calculations is difficult, time-consuming, and practically impossible to do accurately. It's also redundant when manufacturing ERP software can automatically track the numbers for you. For example, MRP Easy calculates OEE from data already being collected for production management in real time. No separate data entry is required. Operators report production activity once, and OEE calculation happens automatically. Reports are generated continuously in the background instead of taking hours to compile. Multiple machines or production lines can be simultaneously tracked, and you have access to both real-time stats as well as per workstation historical OEE data. Here's the bottom line. Software doesn't improve your OEE. It just tracks the data faster and more accurately than humanly possible. But then it hands it off to you. So remember, start with the data collection process. Be honest about what you found, then get busy to make improvements and gauge their effectiveness. Then start all over again. Improving your OEE will raise your profitability, but it's an ongoing task, improving and sustaining your numbers. That wraps up this episode of the MRP Easy Manufacturing Podcast. Thanks for tuning in. For more information, go to mrpeasy.com. See you next time.